another memorization process that you must memorize. Just memorize. Take 214, where you had to memorize the sine of theta is y over r, cosine of theta is x over r, and so on and so forth. Now we must memorize that the sine of theta is the side opposite over the hypotenuse. Well, what does that mean? Well, what that means is in any right triangle, if I want to talk about these two angles, the acute angles, not the right angle, but the acute angle, if I want to talk about that angle, then this side becomes the side opposite, this side becomes the side adjacent, and the hypotenuse is always the side opposite the 90-degree angle, the longest side. So we have a triangle. What this is for is we just have a triangle sitting out here. That's a right triangle. Then if we want to talk about this angle, then the sine of that angle becomes the side opposite over the hypotenuse. We don't have x, y's, and r's. Therefore, we must memorize the 6 trig functions of a right triangle in terms of side opposite, side adjacent, and hypotenuse. You see, if I'm talking about this angle, then this becomes a side opposite, this becomes a side adjacent, and the hypotenuse. So, then that's what you need to memorize. You need to memorize the sine of theta, the sine of A, the sine of B, whatever the angle is you're talking about, in a right triangle, one of the acute angles. Then the sine of that angle is equal to the side that's opposite that angle over the hypotenuse. The cosine of an angle of a right triangle, acute angle, is the side that's next to the angle over the hypotenuse. And the tangent then is the side that's opposite the angle over the side that's adjacent. In other words, looking back over the triangle, the tangent of this angle is this side over this side. The cotangent then is the side adjacent over the side opposite. Well, look how that works for cofunctions that we talked about. The sine is this over this. You remember cotangent is what? That flipped over. Well, look. What is the cotangent? The cotangent is the side adjacent over the side opposite. So it still works. Okay? Secant. Secant then, again, don't forget to always know these concepts, that the secant is the cosine flipped over. The cosine is side adjacent over the hypotenuse. The secant is the hypotenuse over the adjacent. Cosecant is hypotenuse over opposite. Why? Well, one reason is because the sine is the opposite over hypotenuse. Now listen closely to this that you should just stick in your mind and watch out for and remember forever. The sine of an angle is always less than 1 or equal to 1. The sine of an angle is always less than or equal to 1 for this reason. The hypotenuse is always the longest side of a right triangle. So the sine is this side, which is shorter, over this side. And so this is less than this, so when you divide that ratio out, you get a number less than 1. Well, that means the sine and cosine, because the cosine is this over that. So those have to be less than 1. So the sine and cosine of any angle is less than or equal to 1. The only time it's equal to 1 is those special angles, 0 degrees, 180. Well, now let's look back at tangent and cotangent. Tangent and cotangent can be anything. They can be any value, anywhere from 0 up to 10 million. Because it's this over this. And those things could be anything. You could have a triangle like this, where this over this be small, or you could have a triangle like this, where this over this could be large. So the tangent and cotangent have no restriction. They can be any value for any angle. Now, what about secant and cosecant? Secant and cosecant have to be greater than 1. They have to be larger than 1 or equal to 1 because it's the hypotenuse over the adjacent. Hypotenuse is always the longest side. So if you divide a number larger than this denominator, you get 1 point something or 2 point something or something. Some value greater than 1. So the secant, cosecant, always greater than 1. Tangent, cotangent, any values. Sine and cosine, always less than or equal to 1. Now you must memorize those. Have those memorized before you can go much further in trig. All right, now let's look at triangle, just setting out somewhere where we can't deal with x, y's, and r's. And let's come up with the 6 trig functions for those. Well, here we go. Here we have a right triangle, and this little mark says this is the right angle. Therefore, this is the hypotenuse. All right, so what is the sine of that angle? The sine of that angle over there is the side opposite over the hypotenuse. There we go. Side opposite over the hypotenuse. The cosine of this angle is the side adjacent over the hypotenuse. Cosine adjacent over the hypotenuse. The tangent of that angle over there, this is all thetas, the tangent of that angle is the side that's opposite over the side that's adjacent. There it is. Side opposite over the side adjacent. The cotangent of that is the side adjacent over the opposite. And just like I talked about in the tape 214 about x, y's, and r's, you need to know a single entity rather than being able to do reciprocals. Is if the problem just says, I want the cotangent of that angle, then you need to know that the cotangent of an angle is the side adjacent over the side opposite. So there it is, side adjacent over the side opposite. Secant, secant's what? Secant of that angle is a hypotenuse over adjacent. So 73 over 55. The cosecant of that angle is the hypotenuse over opposite. Okay, so again, you need to memorize that, but also don't ever forget that this is flipped over, this is flipped over, this is flipped over. So basically, what I'm saying is this to you. If you memorize these 3, you got the last 3. In other words, if a problem wants the secant of an angle, go do this cosine and flip it over. If the problem wants a cosecant, go do the sine and flip it over. Cotangent, go do the tangent, flip it over. Now, you say, well, why do all that? Well, one reason is because of the calculator. The calculator only has these 3 buttons. So if you want to find the cotangent of an angle, what you need to do is find the tangent and then hit the 1 over x button, the reciprocal button. If you want to find the secant, then you go do the cosine of an angle and then hit the 1 over x or reciprocal button, whatever your calculator has, do the reciprocal. That's why it's important to do that. I do not give you any statement that's a waste of your time. Every statement I give you has a purpose that you will use somewhere. All right, let's look at another concept, and that's now the word cofunction that's in your textbook. Cofunction. Sine, cosine. We'll look at right here. The sine, cosine. That's the same number. Look over here. Sine, cosine. Same numbers. Yeah, because look what's happening. The sine of theta is the side opposite over the hypotenuse. The cosine of the what's called the complementary angle, the other angle of the right triangle, the cosine of that's the same number. Well, look here. The cosine of this angle is adjacent over the hypotenuse, and the sine of this angle is the same number. Now don't get this confused now. Sine and cosine of the same angle, that's not connection. It's saying that the sine of this angle of a right triangle is equal to the cosine of the other angle. The cosine of this angle is equal to the sine of the other angle. The tangent of this angle is equal to the cotangent of the other angle. The secant of this angle is equal to the cosecant of the other angle. That's the word cofunction. In other words, the sine of 10 degrees is equal to the cosine of 80 degrees. These have to add up to 9 degrees. The cosine of 25 degrees is equal to the sine of what? 65 degrees. These have to add up to 90. The secant of 60 degrees is equal to the cosecant of 30 degrees. Cofunction, secant, cosecant. Cosine, sine. Sine, cosine. Tangent, cotangent. So looking at this now, you have to now add something else to your memory. That is reciprocals. Tangent, cotangent, reciprocals. Cosine, secant, reciprocals. Sine, cosecant, reciprocals. Sine of an angle equals the cosine of its complement. Cosine of an angle is equal to the sine of its complement, its cofunction. The tangent of an angle is equal to the cotangent of its complement. Okay? All right. Now, let's look at the last memorization that you need to know for this chapter, and basically that you need to know to deal with basic trig functions in other math classes, physics and some other courses like that. That is special angles, 30 degrees, 45, and 60 degrees. You run across these over and over and over in textbooks. So rather than doing calculators and that type of thing, you can do it this way. All right, so 30 degrees. Now, for 30 degrees, what we do is draw a triangle here, and we say that for this 30 degrees, the side opposite that is 1, and the hypotenuse is 2, because there's a theorem in geometry that says that the shorter side of a right triangle opposite 30 degree angle is equal to 1/2 the hypotenuse. So if you do this squared, r squared is equal to x squared plus y squared. This comes out to be the square root of 3. Now listen to me. What I say to you when you're learning this, anytime you run across 30, 45, 60, sketch that little triangle on your paper, just like I have it in the notes. Sketch that triangle. Okay, go ahead and put the 60 degrees here. Then you can say, all right, the sine of 30 degrees. Sine is side opposite over hypotenuse, so that's 1/2. Okay. Cosine, side adjacent over the hypotenuse, square root of 3 over 2. Tangent is the side opposite over the side adjacent. That's 1 over the square root of 3. Or you'll see in textbooks the square root of 3 over 3. No, these are the same. 1 over the square root of 3 is the same as the square root of 3 over 3. They get that by multiplying the top and bottom by the square root of 3. All right? So just know that. All right? So the cotangent. Cotangent is what? Side adjacent over side opposite. So that's the square root of 3 over 1. But we just write down the square root of 3. Secant. Secant is hypotenuse over adjacent. So it's 2 over square root of 3. Or 2 times the square root of 3 over 3. This answer is just as sufficient nowadays, but you're going to see that written down as answers. Cosecant is 2 over 1. Hypotenuse over side opposite. Now, as I said on the other tape, if you watched it, if you try to memorize all these angles for all these functions, you're going to have such a memory bank in your mind that I think you'll get them confused at many times. I think, again, it's better if you stay with just memorizing, beginning this tape, the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangents opposite over adjacent, and so on and so forth. But now know the cotangents, this one flipped over, secants, this one flipped over, cosecants, this one flipped over. And then all you do, I'm saying that's all you do, but you don't have to add as many memorizations to you. Still, trig is a memorization course. You just have to understand what it is. You draw your little triangle for 30, 60 degree angles, and you just work it from there. If I want the tangent of this angle, then it's the side opposite over the side adjacent. If I want the secant of this angle, it's hypotenuse over side r. Well, if I want the secant 30 degrees, I can do cosine. Because I know cosine is adjacent over hypotenuse. So then I flip it over. All right. Now let's do 45 degrees. 45 degrees, all right? So again, for 45 degrees, what I want to do is draw a triangle that's 1, 1 and the square root of 2. I'm not making up numbers. If you put a 45 degree here, that means these two sides have to be equal. And so if they're equal, I'm just going to make them the smallest number possible, 1 and 1, whole number, integers. So this squared plus this squared is equal to square root of 2. All right, so the sine of 45, here's 45 degrees. Sine of 45 is the side opposite over the hypotenuse. So that's 1 over the square root of 2. R, square root of 2 over 2. This answer is better in a lot of cases in mathematics, but you need to know they're the same. Cosine of 45 is 1 over the square root of 2. It happens to be the same, sure enough. The sine of an angle is equal to the cosine of 90 degrees minus that angle. Well, 45. How about that? Well, let's go back and look at the one we just got through doing, the 30 degree one, and look at here. Hey, I'm going to do this in a minute on the paper, but we can get the cosine of 60. Cosine of 60 must be 1/2. Sine of 60 must be this one. Cotangent of 60 must be this. Tangent of 60 must be this. Cosecant of 60 must be this. Secant of 60, yeah, see, we can use that concept. All right, let's get back to 45 degrees now and finish it up. 45 degrees is the side opposite over adjacent. It's 1 over 1 equals to 1. Cotangent then is 1. Cotangent would be adjacent over opposite. Same thing. Secant. Well, secant is hypotenuse over adjacent. That's the square root of 2. Square root of 2 is 1.414. Look at that. Greater than 1. Up here, this is 0.707. Less than 1. All those. All right, cosecant, hypotenuse over opposite. Same answer. Secant of 45. All right, let's now look at 60 degrees. Okay, remembering now our triangle for 60, which is up here. Okay, this is 30 degrees, 60 degrees. So we're up here at 60. Sine of 60 is side opposite over hypotenuse, square root of 3 over 2. Cosine of 60 is a side adjacent over the hypotenuse, 1/2. Tangent of 60 is what? Side opposite over side adjacent, square root of 3. Cotangent, side adjacent over opposite, 1 over square root of 3. Secant of 60, hypotenuse over adjacent, 2. Cosecant of 60, hypotenuse over opposite, R, 2 times the square root of 3 over 3. And again, it checks out. This is flipped over, this is flipped over, this is flipped over. All right, now that's the things that you need to have memorized in this, out of this chapter 1. Now let's look at some examples using these. All right, some example problems in textbooks are like this, just for the practice, but the important thing I want you to understand on problems like this is what you're doing is working individual parts, really, just for practice. For instance, we want the sine of 30 degrees. Sine of 30 degrees, mentally, let's see, 30 degrees is 1 square root of 3, 2. 30 degrees. So the sine of 30 degrees is a side opposite over the hypotenuse. So that's 1/2. Now, things that you need to know for when you use calculators and other things for this is this type of thing. If that's the sine of 30 degrees cubed, then that means this is the answer of sine of 30 degrees, then that's cubed. So 1 cubed is 1 times 1 times 1. 2 cubed is 2 times 2 times 2. 4 times 2 is 8. So the sine of 30 degrees cubed. Now listen to me. Listen. This says to work that out, I had to do the sine of 30 degrees. I work it out. Then I cube that answer. Well, that means then on the calculator, then to do that you would do parenthesis, sine of 30 degrees, parenthesis, and then cube it. See, don't go put the sine button and then hit the cube button and then put the 30 degrees. That's one of the most important things you can hear about using calculator for doing trig, and that is, this is one single object. That goes together. The sine and 30 degrees go together. Even though they put that 3 up there, it doesn't mean you separate them. You don't do them in that order. You do all of this and then take that answer and cube it. All right, let's look at the second part of the problem. Sine of, let's see, we had a plus sign here. Sine of 60. Oh, well, we'll go draw our triangle again. Sine of 60. Okay, there's 60. 1, 2, square root of 3. Sine is side opposite over hypotenuse. So therefore this is a square root of 3 over 2. All right. Let's see then. Cosine of, cosine of 90. Just we go back to the first tape, 214, and remember for 90 degrees, this is 0, 1. And here we have to memorize X, Y, and R. See, you don't just do all problems opposite adjacent. You don't do all problems X, Y, and R. You have to know both memorizations. So here we're going to do, see, cosine. Cosine is X, 0 over R, which is 0 over 1. R is 0. All right, third part of the problem is the cosine. Cosine of 45 degrees. Well, let's see. We draw our little triangle, 1, 1, square root of 2. Cosine is side adjacent over hypotenuse. That's 1 over the square root of 2 to the 4th power. Okay, so we do the cosine of the angle, then we get that answer, and then we raise it to the 4th power. All right, well, let's see. What is that to the 4th power? 1 times 1 times 1, that's 1. Square root of 2 times square root of 2 times square root of 2 times square root of 2. Let's see, that's 2, and that's 2, so this must be 4. Now here's a case where, to me, it's better to know it this way than to know that square root of 2 over 2. Because then you're going to have to do that, which comes out to be 4, and this, which is 16, and you reduce it. So there's many times when it's better to write the sine and cosine of 45 degrees as 1 over the square root and leave the square root in the denominator. All right, let's come back and finish the problem up now, looking at all of it. 0 times this number is 0. So what we have is 1/8 plus 0 plus 1/4. Well, how many eighths is this? This is 2/8 plus that 8. So final answer is 3/8. Now, purpose of the problem, though, is just practice to know how to do 30 degrees and sine of 60 and cosine of 90 and those type of things. All right, now let's look at the last example on this tape. Big old long one, but it's just stretched out to point out practice, practice, practice. Because throughout other courses that you have to use trig for, they're going to be asking you these type of things. Just quickly, what's the cosine of 60 degrees? And sometimes they're going to ask you that in terms of X, Y's, and R's, and so on and so forth. So it's important to know all this memorization. So let's now look at each part. So let's look at the sine of 90 degrees and the secant of 180. Okay, well, again, that's going to require where we're going to come down and do this 0, 90, 180, 270. See, 90 degrees is 0, 1. 180 is a minus 1, 0. Okay, so let's do sine of 90. Sine is y over r, so that's 1. Secant is r over x, r over x, so that's minus 1. All right, let's move on to the second part of it. Sine of 45. Okay, here's 45. Sine is side opposite over the 8, so that's 1 over the square root of 2. Okay, 180, whoops, there's where we go back to 180. 180 over here is a minus 1, 0. Tangent is what? Tangent is y over x, so it's 0 over minus 1, so that's 0. All right, moving on to the next part. Cosine of 60. Here we have 60 degrees. 1, 2, square root of 3. See, I put the 60 here, and the 30 now is up here. The side opposite the 30 is the 1. All right, so we want the cosine of 60, adjacent over the hypotenuse, so that's 1/2. All right, cosine of 30, well, let's just go back and look at that triangle right there. Here's 30 degrees. We've already drawn this triangle. So the cosine is what? Side adjacent over the hypotenuse, so that's the square root of 3 over 2, and that's all squared. And then plus the cosine of 0 degrees. Well, 0 degrees is 1, 0. Cosine is x over r, so that's 1. So let's go back to the beginning of all this and look at each calculation and put all those numbers kind of together where you can see it easier on the screen. So this is a minus 1. This is 0 times, well, this would divide it out, but that doesn't make a difference. That's 0, so that's 0. And then we have a minus 3/2. And then over here, we have a plus 1. And right here, square root of 3 times square root of 3 is 3. And 2 times 2 is 4. So what do we have? Well, here we have a plus 1 and a minus 1. Those drop out. And here we have, let's see, if I multiply the top and bottom by 2, I have a minus 6 fourths and a minus 3 fourths. So therefore I have a minus 9 fourths for a final answer. Okay, this now concludes the tape on Chapter 1.